Hello everyone, welcome to this recording. I'm doing this because yesterday we didn't have the time to go through this R script. So in order not to in order not to lose much time next session, please check this recording and type along this video. So first of all, in this candy vector, we're going to put the numbers with which we worked yesterday to calculate the median and the mean. So I'm sorry, I'm going to delete this. Sorry. Okay, let's just delete this. Okay, so here are the numbers. Okay, so this is the vector which we are storing in this variable called candy. Okay, so let's calculate the mean and the median. Calculating. I recommend you to put comments or to write comments in your code, in your scripts, because in this way you can remember what you did in your code. So for example, if you are preparing for the exam, you can understand and remember better the functions and all the scripts. Okay, so I didn't run this, so here I run it, and then let's run this, the mean and the median. So yeah, 3.4, and then the median is 3. Okay, this is the structure. Looking at the structure here, which is only a vector, nothing, not too much to say about it. Then we can check the summary. Checking the summary. The summary is very informative because, as you can see here, if you run this, you can see the minimum value, the first quartile, the median, the mean, the third quartile, the maximum value. In this case, you only have here 14 numbers, but in case we have 100 or 1,000 of numbers, this is very informative. So let's create a box plot. Creating a box plot for candy. On your right bottom corner you can see the box plot, but it's not very informative. So let's put some labels to the box plot. So let's say box plot candy, name, which is the title of our plot, box plot of candy, the X label, which is put like this, only candy, and Y label, we can put a number of candies. Okay, we run this and you can see that it's more readable, way better than the other one. Let's say that you can see, let's say, like if we remember yesterday about our discussion regarding the outliers, let's imagine that, for example, instead of 8 we have a 10. So we run this again, we run the vector, and we run the box plot again. We can see that 10 is an outlier. Okay, we check again the structure, the summary of this vector. So we can see that the median stay the same, the mean changed, and also let's say only the mean and the maximum value changed. So let's say that we want to know the limits of the upper limit where the outliers are going to be located. For example, let's say that our first quartile is, let's put it like this, first quartile is equal to 2, as you can see here. Sorry, third quartile, which is Q3, is equal to 4.70. Okay. So, and then we just calculate the interquantile range, which is this difference between Q3 and Q1. I'm creating a key comment and calculating the upper and lower limits. So lower limit is equal to Q1 minus 1.5 times interquantile range. Upper limit, which is equal to Q3 plus 1.5 interquantile range. Okay. I'm just checking the length of this candy. Okay. So now we can run this, and yeah, nothing happened because we just store variables here. And let's add this line to see the limits on the graph. We create this function, or we run this function, which is upline h, which stands for horizontal line. We put here the vector, which is lower limit, upper limit, and color equal red. So yeah, you can see that this is the limit. So all values above this limit, this upper limit, will be considered outliers. And if you here, the lower limit is not shown because the scale here is only from 0 to 10. For example, we check the value of lower limit, which is minus 2.1. So yeah, this is not possible to see it here unless we change the scale here on the y-axis. So this is a recap of how we can calculate these several numbers for a box plot. If we want to see a histogram for this vector, we can also create a histogram. Okay. In this case, you can see in your script, it says, let's see how we can make this more normal. So we apply logarithmic function to candy. We can see that it changes. We are doing this, or we are applying logarithmic function because to reduce the scale, to reduce the influence of higher values. Okay, so let's see, for example, then instead of 10 we have 100, and we run the histogram. Okay, and then if we apply logarithm function, we can see it in a better way. Okay, but yeah, you can try this out with different numbers. You can add more numbers here. So yeah, it's up to you. What else here? Okay, so you can check your working directory here. Okay, it's fine. If it's not your working directory, you can copy and paste the path here. Yeah, this is an error because I didn't put anything. Or you can go to session, set working directory, and choose directory. And now let's work with our survey results from the file from GitHub. So let's run survey. So we are storing this file into this variable, which is called survey. We attach it, and we can check the structure. But if you want to check the structure, I recommend you to go here to your left, sorry, to your right, to this window on your right top, and in this arrow you can see the structure. If you apply here view, you can see all the table. Okay, you can do the same if you here in this icon, you can click here and you can see also the table. Okay, so before going or moving to chisquaretest, let's see box plots for this data, for real data. So box plot, for example, for, let's see which variable we have here. Sleep, hours of sleep. Okay, we can put here sleep, but let's create some labels. I'm just going to copy and paste this. Probably I'm spending more time doing this than writing the whole thing from scratch. So box plot for sleep hours. What I did here, just to next to the comma, I pressed enter just to make to go to another line, so it's more readable. X label is to say that sleep hours. Let's just put here sleep hours, number of hours here. So let's run this, and you can see that it's more readable, yeah, more or less. You can zoom it. Okay, you can see that the median is equal to the third quartile. Let's check, for example, if that's true. Summary. I forgot. I mean, we can use this attach here. Sorry, we can use this the name of the column, just like that. But in case we have several data frames with which and columns with the same name, could be a bit problematic. So we can survey. I prefer to do this. So also because in another languages such as Python, we also have to do that. Survey, sleep, and yeah, you can see that the third quartile is equal to the median. Okay. So again, this depends of the values in the distribution on the rank when we ranked and we order the data. So where was I? So yeah, let's create this comment. Create box plot for variable sleep. But there's another way. For example, let's see that comparing, I'm just going to go here, comparing sleep hours between majors. So as you know, here we have the major variable, which are those students who are studying global environmental and sustainability studies, and those who are studying UV. So let's create this box plot, which is very interesting. So let's say, for example, in this case, we have to change the syntax a bit. Let's put here, let's say, please, I need to see plotted the sleep hours, or the variable which is called sleep, in reference to the major variable, coming from the data survey. So in this case, it's no longer necessary to put survey sleep serving this $sign. So it's just enough doing this. So I run this, you can see two tables. Okay, you can see the box plots for the UV and for the global environmental students. So visually you can see that pretty similar. We're not doing here any test, just to comparing visually the distribution of the data. Okay, so you can I invite you to experiment with other variables. For example, instead of major, let's see the variable season. Let's see, for example, here I forgot to change the label. Here's season. Okay, so we can see the way we interpret this graph is that people or students who like fall season sleep this amount of hours. Those who likes winter season, you can see that they responded that they slept less in general, or the distribution is more concentrated in this between 7 and 8 hours. Okay, so you can see that in summer, spring, and fall, those students, the sleep of hours they like to, the students who like these seasons, they slept these hours, and there's more variance in those distributions. Okay, so you can play around with the variables in creating your box plots. You can add colors, etc. For example, coal, blue, and you have blue. Okay, so I invite you to play around. Okay, and comparing the sleep hours between students, seasons preferred by students. Okay, now let's move to chi-square. So before that, let's, for example, again, I like to do this better, like survey. I know it's more typing, but it's safer this way. So let's create this table, for example, like the example that we worked yesterday. We have pineapple pizza, the students who the students who mind or don't mind to have pineapple on their pizzas, and those variable which tells us the students who prefer Windows or sorry, Microsoft or Apple. Okay, so let's create this table, this continuity table. So similar to what we have yesterday. If we want to, for example, to change it, let's change the order. So survey OS survey, just to have it pineapple pizza. Yeah, like yesterday, similar to what we had yesterday, but yesterday we only had Apple and Microsoft. And the thing here is that, for example, just putting here, changing the order. In here I am what am I doing here? Yeah, let's run right away so to run the chi-square test, you first need to create the table. Okay, and then you have to put this table inside this function of the chi-square test. So we have this function. You can learn more about it with the help function. Okay, So now we put here, and then we run this. So we have our values here, but we got a warning message. This warning message, we have to consider it. Please don't ignore this warning message. The thing here is that, again, if you can see here, the contingency table is that based on experience and other mathematical studies, that chi-square test doesn't work or produces unreliable results if you have frequency counts below 5. So for example, we have very low frequencies here, which can affect the test. So below 5 is not recommended. So here both also you have very low values compared to the others here. So that's why yesterday in our example we only work with Apple and Microsoft, and we did not consider both in neither. So how are we going to select only Apple and Microsoft based on the data that we have? So this is very interesting, very useful for you to know. So let's see here, selecting variables or columns, not selecting, just filtering values according to some criteria. So in this case we are filtering the columns that contains only Apple and Microsoft. Okay, so there's one way of doing this. For example, you can choose, as you can see, it's already written here. Here what you're saying is, please R, I want this column. Let's put here survey $signs pineapple pizza. From this column I want to get only the results for Apple. Okay, let's run this. So what I'm doing here is that we are filtering, so we are retrieving the values for pineapple pizza, but only related to in relation to the Apple values in this how to say that, in this column. Okay, let's repeat again. Another way to do this, which is, I think, is more to say that you can understand better, is if you put, okay, I have this data, my data frame, which is survey. I want to select to say that the operative system, which is OS, equal to Apple. Here you have to be very careful, because in this case you have to put twice equal sign. Okay, and let's say, yeah, I only want the you can put it like here, pineapple pizza, and you get the same results. So again, you're saying, please, I want to get the results of this column, but based only if I filter this column with the value with Apple. Okay, another way of doing this, let me check, because I had here another way of doing this. Sleep survey. Okay, let me put it here. Yeah, I have 3 way. I mean, you can use this way. So for example, one way of selecting, second way of selecting, filtering, third way of selecting, filtering. So this you're saying, yeah, I want the subset, like a small piece of the data frame, where, so this is the data frame. Please select, let's say, only pineapple pizza, and when, according to this condition, when OS is equal to apple. You have here a subset, okay? For example, if you want to see, let's say that you want to see also the OS variable, you can put it here. So this is more readable. I think it's better to understand. So when I'm saying here, like, please, from this data frame, I want this column, but only with Apple results in this OS column. So as you can see, there's no Microsoft, there's no there's no both value here, only Apple, and you are getting the respective values of pineapple pizza. Okay, if you can see, for example, if you want to see also Microsoft and OS equal Microsoft, I made a mistake here, I think. Let me check. Microsoft. Okay, I think we have to put here into values. I got an error here, I think. Yeah. Yeah. Let's wait. I have a problem here. Pineapple Pizza OS. For example, if you want to see only Microsoft, see, for example, filtering only by Microsoft. Okay, I don't remember how it was. Let me check. I think this is the way to do this. And OS equal Apple. Yeah, so this is the way to do it. So for example, I'm going to do this. So for example, you are saying, please, I want from this survey data, I want these two columns, but only when in the column OS, the values of Microsoft and Apple appear. Okay. You can see here. If you can see, for example, also both, neither. Okay, you can see here that it's only neither or both. Okay, so these are the ways of selecting things, and I recommend you to how to say that, to play around with selecting other columns and applying other criteria. Okay, so now let's get to the key square. Okay, so for example, now we have to get rid of both or neither. Okay, so we say pineapple pizza, I want this column. Okay, let's put it like this. Pineapple pizza, survey. Okay, so now you have to create this table first. Let's say that you can put everything here. For example, you're creating a table and you put this whole thing here, and then you have this small table. But for you, I mean, I think it's like you are very likely to make errors if you put everything here. Okay, so what I recommend you is to create some extra variables. So let's say creating or storing pineapple pizza column, the filtered pineapple pizza column, into another variable which is called, for example, let's say let's say pizza it's equal to, when we put here, we delete this. Okay, so what we are saying here is, okay, from survey I want this column pineapple pizza, but only those values that are related to the Apple and Microsoft values. Okay, and I want this to be stored here in pizza. But the same we have to do for the OS. So you can put OS filtered. You can put here also pizza filtered, and we put the same here. You can just copy and paste. Okay, survey, I want this column OS. Okay, and everything stays the same, and I'm storing this in OS filtered. Okay, I run both lines. Okay, and now if I create this table again and I put pizza in OS, pizza filtered in OS filtered, voila. Okay, let's put it the other way around. OS filtered, pizza filter. Okay, now we have the table, the contingency table, as like the same structure as we had it yesterday. Okay, now we will have frequency values below 5 or below 10, but we can work with this and we are expecting not to have any errors. Okay, so let's put here creating the table, contingency table, and then applying chisquaretest. So just put the function here, q test. So you also have two options. You can put here this, and you have your values. Okay, Remember that those values here are not the same like the ones we had yesterday. The numbers are different, so that's why the p-value is different, and also the chi-square is different. So again, we have to, our null hypothesis is that both variables are independent, there is no pattern between them. So yes, we cannot reject this hypothesis, so there is no dependency between them. Oh, you can see, like, for example, you can do again contingency table, and you can put here in table here and put it here. Okay, create more variables. I mean, it depends if you want to create more variables or not. You get the same result. Okay, then you put here contingency table, and you have the same output. So this is another way of doing it, like the one that was already written here. But as I said, personally, it's, I mean, if you type from zero, is like it would be very likely to get errors, but you can try it out. Another thing is that, for example, getting observed and expected values. For example, from this chi-squared, let's say we put here and we put $sign observed. So we have the ones that we observed. We can retrieve also. I'm copying and pasting again. And expected. So yeah, I have expected values. Okay. So yeah, this is the chi-square test. Like a quick recap. So first of all is to look at your contingency table. You create this contingency table with the table function. You put your columns or your variables, categorical variables. Don't forget. You have to chi-square test unreliable. So you can see here that the if you run this, you can see that the chi-square is not running. You have this warning here. Okay, you can see the expected values also from here, but then we have to realize that we have to eliminate these both in neither values. So we had to filter the columns excluding these values. So we have here, for example, different ways of filtering, selecting. We have this way, we have this way. Okay, you have another way, the third way. So just play around with those. This is how you select for both values. Okay, and then we also store these columns already filtered into these variables, and we create the contingency table now with the columns filtered. Then yeah, we created our, or we ran our chi-square test. What else? You can run this, for example, as an example from R. From values, you can study this, looking into this for more detail. But finally, is that in this survey, even though it's super clean, we still have non-values. Non-values are problematic because some functions tests cannot run if we have non-values on NA. null values or NA are values that are, please remember that null values or NA does not mean zero. Zero is a value, but a null value or a NA value is something that doesn't exist. That's why software have problems when dealing with these values, with these NA or null values. So you can here check these functions. Well, for example, first let's see how many NA or null values we have in our survey. So we put this is NA and then survey, and then sorry. So we as an output we have this table, but we don't. This is hard to read, so we want to check. So how many NA values do we have in survey? So you have to sum this. You're summing null values. You have 40. This is for the whole data frame. If you want to check checking by column, sum is an A survey, let's say with one's countries, 2 null values. Okay, for example, again for another column you can play around also to check another null values here. Let's say happy to 0. Okay, and if you want a new data set or data frame without null or without NA values, you apply this function na omit. You put here survey. We create a new survey that we store in this new variable. Survey, the original one is untouched. So we have, for example, now we have survey and survey new. If you want to export this survey again to your folder where you are storing your data in scripts, you put this function write.csv, the name of the survey, and the name you want this file to have on your folder. So you put this. Now, for example, let's check if I want to open this file. You can see that, yeah, survey, this is the one that we just created, survey 24 NA out. Okay, I can open it, okay, but I don't want to do it right now. You can read this survey and attach it and work with it as normal. Okay, so if you have any questions, please hit me a message on Discord or via email. Also, as a disclaimer, I'm not used to making videos, and also I'm a bit nervous talking in front of the camera without an audience. So please apologize for if my pronunciation is not the correct one, of if I'm talking a bit strange. Yeah, but I will keep improving this kind of recording videos. Okay, so I hope you have fun with this, and see you next session.